learn what is the Rolle's theorem and the graphical meaning as well. Today we are going to solve some application of Rolle's theorem and do some entrance question. This is our first question. We will verify Rolle's theorem and find the value of c. For f of x is equal to x square e minus 1 to 1 close interval, then f of x is equal to sin x by e to the power x in 0 to pi. So question 1. Here f of x is equal to x square. So clearly this is a x square, right? The graph is like this. This is continuous as well as differentiable on R. So it is continuous and differentiable on minus 1 plus 1 close interval. As f of x is continuous plus differentiable on R. So it is continuous and differentiable on minus 1 close interval. And if we find f of a, f of minus 1 is equal to f of 1 is equal to 1, right? So f of a is equal to f of b, and function is continuous on close interval a b, and function is differentiable on open interval a b. As for conclusion, there should exist a c belongs to minus 1 to 1 such that f dash c is equal to 0. Let's find such c. Here f dash x is equal to 2. So f dash c is equal to 2, c is equal to 0. Same like c is equal to 0. So what we get, there exists c is equal to 0 which belongs to open interval minus 1 to 1 such that f dash c is equal to 0. So we get c which is belongs to minus 1 to plus 1, open interval minus 1 to plus 1 so that f dash c is equal to 0. So Rolle's theorem is verified. We will get such c, right? So first question is done. Now solve second question. Here f of x is equal to sin x by e to the power x in 0 to pi. Sin x by e to the power x in closed interval 0 to pi. Clearly sin x and e to the power x continuous plus differentiable on R, right? And e to the power x is not equal to 0 on R. So f of x is equal to sin x by e to the power x is continuous on close interval 0 to pi. Differentiable open interval 0 to pi. Third point is f of 0. What is f of 0? Sin 0 by e to the power 0 is equal to 0, which is equal to f of pi is equal to sin pi by e to the power pi is equal to 0. So implies f of 0 is equal to f of pi. So three hypotheses satisfied. Now we have to find c. To find c, we will go like reverse way. Let f dash c is equal to 0. What is f dash x here? Derivative will be e to the power x, derivative sin x is cos x minus sin x, derivative e to the power x is e to the power x, taking e to the power x common by v. So this is your f dash x, e to the power x with cos x minus sin x by e to the power 2x. We can cancel e to the power x. What do we get? Cos x minus sin x divided by e to the power x. So what is f dash c? Cos c minus sin c divided by e to the power c is equal to 0. it is less than equal 0, right? That means cos C is equal to sin C. So implies tan C is equal to 1. So implies C is equal to 584 plus n5 we can take. N belongs to integer z. But if it like we need at least one, right? But for our convenience we are taking it C is equal to 584 which belongs to 0 to 5. So what do we get? We get C which is lying between open interval 0 to pi such that if their C is equal to 0, that means Rolle's theorem is verified. This is also done. So we verify Rolle's theorem and find the value of C. Let's do some competitive question. This is the most important question. Just understand, this is like the topper part is the language. You have to understand the language what this question exactly asking. Then solution is easy actually. Let's understand if alpha 0, alpha 1, alpha 2, alpha n are real number such that this condition is satisfied. Okay. Then show that we have to show there exists at least one x minus to 0 to 1 so that this thing is happening. There is at least one x minus to 0 so that this thing happens. Like from Rolle's theorem we can move from reverse, right? This is our f dash c. This is our f dash c. There exists at least one x minus to 0 1. That means this x like c is replaced by x, right? So if dash x is equal to 0, this is our f dash x. So how to solve this type of question? Like this. Let f dash x is equal to this alpha 0 x to the power n plus alpha n minus 1 x plus alpha n. F of x is nothing but integration of f dash x dx. This is equal to, this is a polynomial, right, basically. So instead of integrating individually, we will get alpha 0 by n plus 1 x to the power n plus 1 plus alpha 1 by n x to the power n plus we integrate this term, we get alpha n minus 1 by 2 x square plus alpha n x. This is our f of x. Clearly, f of x is a polynomial, right? So it is continuous. So Rolle's theorem hypothesis, f of x is continuous in our domain is 0 1. Close interval 0 1. Second point, f of x is differentiable in open interval 0 1. And the third one is most important to verify. What is f of 0? We are putting x, the value of x 0. This is 0 0 0 0 0. Every term contain x, right? So f of 0 is equal to 0. Now f of 1. So x is equal to 1, then what we get f of x? Alpha 0 by n plus 1 plus alpha 1 by n plus alpha n minus 1 by 2 plus alpha n by 2. Look at the condition what it is giving starting. Alpha 0 by n plus 1, alpha 1 by n plus alpha n minus 1 by 2 plus alpha n is equal to 0. The same expression, right? So this is 0. So our third condition satisfied. That is f of 0 is equal to f of 1 is equal to 0. Then by Rolle's theorem, there exists C belongs to 0 to 1 such that f dash C is equal to 0. which implies what is your address C? This is your address C. That means alpha 0 C to the power n plus alpha 1 alpha 0 to the power C to the power n. Alpha is equal to 0. This is what we need to prove, right? Look, this is a variable, just variable. Like instead of same, you can put x. It is not does not matter. There is at least one x belongs to C, so that this can happen. By rules theorem, right? There exists C. You can say this is at least one. This is at least one. At least one C, right? So instead of C, you can put x. So which implies alpha 0 x to the power n plus alpha 1 x to the power n minus 1 plus alpha n minus 1 x plus alpha n equal to 0. So the key thing is to understand question and doing reverse way. Yeah, here also we can like add the constant, integration constant like k, and it does not matter actually. This is nothing but this is 0 plus k, this is also 0 plus k, then it is nothing but this k. If we add, if we stay with okay, otherwise you can let solve k, then it's same thing will have to repeat. Yeah. Let's have next question. This is asking JEE actually, JEE 2004, old question. Yeah. Using Rolle's theorem, prove that there exists at least one root in this interval of the polynomial this, right? This is your polynomial, right? So what we like, suppose there exists root, our root is C, suppose there exists C in this interval. Okay. So proving P of C is equal to 0, right? But like from here we can observe like related to with the Rolle's theorem, this is nothing but our f dash is equal to P of C, right? So again instead of C we can write x. F dash x is equal to P of x. So f of x is nothing but integration of P of x dx. This is equal to, just integrate it, 51 by 1 and 0 to x to the power 1 0 2 minus 2 3 2 3 by 1 0 1 to the power 1 0 1 minus 45 by 2 x square plus 1035. This is your f of x. This is important. Clearly, f of x is continuous in this interval. This is polynomial, right? As well as differentiable. Now the concern is what happened at the end point. Here also you can add integration constant. This is like optional. You can skip also. So at the end point we will check 1 by 1 0 0. Like if we put the value of x is 45 to the power 1 by 100, then after some calculation we will get this k. Like, I just keep the calculation. If you want the calculation, just leave in comment box. Similarly, if we find the value of f at 46, we will get k. Both are equal. So continuous differentiable at this point is same. So by Rolle's theorem. there exists C belongs to the interval of the f dash C is equal to 0 implies P of C is equal to 0. That means P of X has at least one at least one root in this is what we need to do on that side. We need to just go back direction from the Rolle's theorem. Let's solve another question. Let's solve this question. This is one of the most important question based on Rolle's theorem, which is asked higher mathematics as well. If we go after master also, let's understand what is the question exactly. Let f is a C3 function on closed interval if f has 7 distinct roots. F of x has 7 distinct roots, it is given in closed interval. Then show that f triple dash x has 4 distinct roots. What do you mean by C3? F dash x, f double dash x, triple dash x exist, and f triple dash x is continuous. So what is given? Just understand what the question exactly talking about. F is C3 function, okay, and suppose alpha 1, alpha 2, alpha 7 are distinct, such that given that 7 distinct roots in closed interval, f of alpha I is equal to 0, I 1 to 7, and alpha I belongs to interval this. This is our given, so we have to prove if triple dash x has at least 4 distinct roots. Let's represent the graph. Suppose this is your alpha 1, this is your alpha 2. These are distinct number, right? So we can represent this number, right? Alpha 4, alpha 5, alpha 6, alpha 7. Here. F dash of alpha is f of alpha is equal to 0 given. So, what is the requirement of Rolle's theorem? F of x is continuous and differentiable. Here, f belongs to C3. That means f dash exists. That means f of x is continuous and differentiable. F double dash also continuous, differentiable. F triple dash also continuous. So, let us suppose we have care about f dash x. Yeah. F dash x is continuous plus differential, and f of alpha 1 is equal to f of alpha 2 is equal to 0, right? That means continuous differential at the end point. Like if we consider this is your interval, at the end point function is very same, equal to 0, and function is continuous differential. That means further means by Rolle's theorem there exists C1 belongs to this interval such that f dash C1 is equal to 0. Similarly, here also there exists C2. Here also there exists C3, C4, C5, C1, C2, C3, C4, C5, C6. Here f dash of Ci is equal to 0. So what we observe, f dash have how many roots? 6 distinct roots. Similarly, observe for f double dash x. Observe f double dash x continuous since belongs to series. Continuous plus differentiable and f dash c1 is equal to f double dash c2 is equal to 0. That means by Rolle's theorem, continuous differentiable endpoint like this. You understand, right? So in between C1 C2, if we take like the interval at this point, this is a new interval. There exists a root, suppose D1, such that there exists D1 such that f double dash D1 is equal to 0 by Rolle's theorem. Similarly, in this interval there is D2, there is D3, D4, D5, so that f double dash dA is equal to 0. So what we observe implies f double dash has how many distinct roots? 1, 2, 3, 5. This is like all the roots are lies in closed interval area. They see somewhere here or A and here or B. Now observe for f triple dash. F triple dash is continuous, right? Cross differentiable. Transfer element is given C3 forms now. Plus f double dash d1 is equal to f double dash d2 is equal to 0. Like the function value at d1 and d2 same, and the function like f double dash is continuous plus differentiable. That means there exists a C. Let's assume this is E belongs to d1 comma d2 such that if our function is f double dash, right? F double dash at point E is equal to 0. So implies f triple dash at point E is equal to 0. So implies is done. Suppose this is somewhere our d1 is somewhere our d2. In this interval, there exists some e1, such that if triple dash e1 is equal to 0. Similarly, here exists e2, here exists e3, here exists e4. Like there might be possible in this interval d1 d2 there exists more than one, right? But Rolle's theorem implies that there is at least one. So we get e1 at point e1, e2, e3, e4. What happens? If triple dash ei is 0. So what it implies? We got E1, E2, E3, E4 all are distinct, right? Let me write like that. E1 not equal to E2, not equal to E3, not equal to E3, E4, and if triple dash of Ei is equal to 0, where I is greater than equal to 1, 4, which implies if triple dash x has at least 4 distinct groups which are lies in impact operator weakness. Since like here EIs are lies, all this happens since EI is given. This is what we needed, right? As proof. So like based on this same concept, like if we go a 4 time derivative, then 1 root is less, 8 times, 6 times, 7 times. So based on this concept, a lot of questions are asked in JR advanced itself. So thank you for watching video. We'll see like if you want some clarification on some concept, just ask in the comment box.